All right, so this is 18.1, part 2. So we're on example 4. Now, when you are looking at this and it says find the value of x, you need to probably determine, find yourself a right triangle. Okay, so you're going to have to draw an auxiliary line. An auxiliary line is not one that's in the piece, but one that you can guarantee measurements for, at least for the sides. And what you see right here is a rectangle and a triangle. If I were to draw this line going straight up right there, even if I don't draw it perfectly, I'm guaranteed to have made a rectangle with right angles like that. Okay. Now, if I draw it that way, or if I want it that way, then I can come up with a line that, when drawn down at a straight path, perpendicular to that side that's 18, I'm guaranteed that its measure, because of the properties of rectangles, is going to be the same measure as the side to the right of it on the other side of the rectangle, x. So both sides are going to be x. And I've made myself a right triangle that, if I know two of the sides, I can come up with a third using Pythagorean theorem, which I do know. If this whole side is 18, then the whole thing is 18, and I know this side is 5. What does it make that side? What does that side have to be? And it would be 18 minus 5, which is 13. So I would know that that side had to be 13. So I've drawn an auxiliary line. I've cut off 5 units from that top side in order to create a rectangle and a right triangle, for which I know the sides, 2 of the 3 sides, and can solve for that x, that height of the rectangle or triangle also. So if that's x, then I know the hypotenuse is right here of my right triangle, hypotenuse, and I have a hypotenuse and a leg and a missing leg. So if I want x already solved for, then I can take the hypotenuse squared and subtract the leg squared. Okay, or you can set up Pythagorean's theorem and then solve it for x, and you're going to get to right there. All right, so 16 squared minus 13 squared. So if I plug that into my calculator, square root of 16 squared minus 13 squared, then I get radical 87. Okay, and if I toggle that, I can get an approximation of 9.327. All right. So radical 87 is the exact answer. It's exactly how long that hypotenuse is, or 9.327, that's an approximation. Okay, so I did that first by drawing an auxiliary line. This one right here, I'll make it red. Drew that down, forming a rectangle of which I'm guaranteed the same height and the same side measure, 5. Subtracted that from the 18, came up with that other side to get 2 of 3 sides of a right triangle, and use Pythagorean's theorem to come up with that side measure. All right, looking at example 5. So example 5 is you're looking for the hypotenuse of this right triangle, but this one is a little different. It has 3 triangles, a left one that's a right triangle, a right one that's a right triangle, and then a big one. So in order to come up with x, this side, I need at least 2 sides of that triangle, so I could find the third. And I see a way. I know this whole length is 44. If I subtract 16 from 44, then I get 28, which would be this side measure, 28. Okay, now I have 1. I need one other one. I need this one right here, right? So I have a right triangle to the left here, and I can use this right triangle, the 16 and the 22, the hypotenuse is 22 and the leg is 16. I can use those to come up with this side right here. We'll call it y for now. And then once I have it, then that would give me the 2 sides necessary to find x of the right triangle. Okay, so we have 22 is the hypotenuse squared minus 16 the leg squared. Okay, so square root 22 squared minus 16 squared is 2 radical 57. Okay, so 2 radical 57 All right. Now I can use my other triangle. X is this time the hypotenuse of this triangle. Maybe I should use a different color. So that's X. It's going to be the square root of the sum of the squares of the length. So 2 radical 57 squared plus 28 squared. Kind of ran into that other triangle question, example 6. All right, so how do I square that? I can just plug it into my calculator, and that wouldn't be any too rough. This squared is going to be 4 times 57 plus 28 squared. And it might be easier to do that. And it's already squared because 2 squared is 4 and radical 57 squared is 57. So in my calculator, I could have just placed it in how I had it originally, or I could make my strokes a little less by squaring out that 2 radical 57. It's 228. So that means I would put in a square root of, let's see, square root 228 plus 28 squared. Don't square the 228. That's already been squared. It was already something else squared. So it's 31.812 units would be that side measure. Okay. Example 6, I'm going to probably have to use a different color here. I'm just going to use this color. I've never used it before. Well, that's kind of cool. Okay, so we're asked to find X. X is a compilation of 2 parts. It's this side plus this side. So I'm going to have to find 2 sides of the triangle. Luckily, I know 2 other sides in each case. I know the 14 and 12 to come up with this, and I have the 12 and the 29 to come up with this. And adding them together in the end will give me the total side, which is X. All right, so I'm going to have to come up with 2 different triangles. The left triangle, I have 14, which is the hypotenuse. This side, which is 12, it's a leg. So I'm going to put square root of 14 squared minus 12 squared. And then on the other side, let's see. Actually, I'm just going to do this. 14 squared minus 12 squared, and I'm going to add to that because that's going to be y right there. And then z is going to be 29 squared because it's the hypotenuse minus the leg squared, 12 squared. Okay, and that's z, and I'm going to add them together to make x. Okay, hopefully that's not beyond you guys. I'm pretty sure you're good with that. So in my calculator, I can even bring it over. I am going to put in 14 squared, square root of 14 squared, forgot what it was, minus 12 squared. All right, arrow out, and that's y. And then I'm going to add to it the square root of, was it 29 squared minus 12 squared? 29 squared minus 12 squared. All right, and that's going to give me square root of 697 plus 2 radical 13. Okay, and then, hey, calculator disappeared when I wrote on that. Okay, and then I'm just going to hit my toggle button. It will tell me what it is. So 33.61. 33.612, actually. All right, and that's in units. So that's how you would do that one. Now, we have a converse theorem. The converse theorem, Pythagorean converse theorem, remember the converse theorem switches the hypothesis with the conclusion. I don't know if you remember that. If it is a cow, then it will move. The converse would be if it moves, then it is a cow. Well, the Pythagorean theorem, converse says, remember the Pythagorean theorem says if it's a right triangle, then a squared plus b squared equals c squared. The converse will say if the square, so if a squared plus b squared equals c squared, then it is a right triangle. So if you don't know that it's a right triangle, you can test to see if it is a right triangle by using the Pythagorean converse theorem. So it says if the square of the length of the or the longest side, I think is what this wants, longest side of the triangle is equal to the sum of the squares of the other shorter sides, I guess. So that's basically saying if c squared equals a squared plus b squared, then it is a right triangle. All right, so then it would be a right triangle. So it says, that's kind of a weird way to put it. If a squared plus b squared equals c squared, if you test it and you check it out and you check both sides and indeed they're equal, if the square of the hypotenuse is equal to the square of the sum of the sides, then it is a right triangle, is a better way to put that. Much more simple and easy. All right, I only have a few minutes, so let's try a few of these examples. Example 7 says, gives you the three sides, 5, 12, and 13. Well, we don't know if it's a right triangle. We're asked to determine whether or not it is a right triangle, first of all, and we don't know which is the hypotenuse, because we have to square the hypotenuse and then see if indeed that is equal to the sum of the squares of the sides. But we do know that this will be the hypotenuse, don't we? Why? Because it's the longest side. So we're going to take 13 squared and see if it's equal to, in fact, I probably shouldn't even just think it's equal. If it's equal to 5 squared plus 12 squared, if that's true, then we know it's a right triangle. So 13 squared is 169. And then I'm going to put in my calculator, 5 squared plus 12 squared, and see what that is. And I can just put it all in as I see it. Oh, it is 169 also. So they are equal. And because both sides are equal, then you could say that, yep, it's a right triangle. All right. So that's what you're going to do every time. Of course, they're going to try to do everything they can to make it a little more difficult. Radical 119. Now, first thing we have our radical 19 as a side, 9 as a side, and 12 as a side. Now, 12 is the number I know to be the biggest, but who knows what radical 119 is? Well, I know radical, what's the closest? 121 is 11. So 11 squared is 121. So I know that this is going to be a little less than 11. Less than 11. So I know 12 is the longest side. So I'm going to check 12 squared and see if that's equal to radical 119 squared plus 9 squared. Now, I'm going to do this without a calculator because I love it when it's radical 119 squared, because the square undoes the radical and it's just 119 plus 81. And is that equal to 144? 12 squared is 144. And it doesn't look like it is it? 119 plus 81 is going to be quite a bit, 200. So 114 and 200 are not equal. And that means that no, not a right triangle. It's kind of an angry looking note. Oh well. All right, I'm down to 14 minutes, so I'm going to run out of time. I'm going to do the last two on my video 3. So stay tuned. Click on the video 3 next.